So I'm going to go through some of the equations of motion, sometimes known as Suvat equations because of the use of the notation SU, V, A, and T. So in the data and formula booklet that you really need to get familiar with, you're actually given quite a few of these. So you're given V equals U plus AT. You're given S equals U plus V over a half multiplied by T. V squared is U squared plus 2AS. And S equals UT plus a half AT squared. I'm going to show you where these come from. The first one to have a look at is S equals U plus V all over 2 multiplied by T. Now, what you may notice is that actually that's the average speed. You've got two different speeds. You've got the start speed and the final speed. And if the acceleration is uniform, which is what we have to expect, so it has to be uniform acceleration for these equations to be valid. If the acceleration is uniform, then this equation is valid, that the distance traveled or displacement S is given by the average speed multiplied by the time. If you were to plot a graph of V against T, and you were to have an acceleration like this, so that's meant to be a straight line, it's uniform acceleration, that's the initial speed, that's V is a function of T, and if I call this my final speed, and that's the time it took, then you know that from GCC, you know that the area under that graph is the displacement. So the displacement is the area under that graph, and there are a number of different ways of solving it. One way of solving it is to use the trapezium rule, but really the trapezium rule is saying, look at this side, look at this side, what's the distance between those two sides, find the average of those two, and multiply it. So we're then finding the area of this rectangle. So we're finding the area of this rectangle, which has a little bit missing here, but that exactly corresponds to the extra bit here. So it adds together. So we can do it as trapezium rule if you like. It's a half of U plus T, so U plus V, multiplied by T. And that gives you one of the equations of motion, and that should make sense to you.